Okay, question 1. A moving sidewalk in an airport terminal building does what? Moves at 1 meters per second and is 35 meters long. Okay, so everyone, question. Who do you think sees it move at 1 meters per second? Person where? So obviously, again, if you are on the moving sidewalk, do you see it move? No, because technically you're moving with it, right? So to you, it's moving at a speed 0, which means it's not moving. But if you step outside, then you see it what? Then you see it move. So it's moving at 1 meters per second. Did they tell you which direction? No, we can pick any direction if we want. Okay, so we'll pick a direction later. If a woman steps on at one end, it's 35 meters long, and walks at 1.5 meters per second relative to the what? Relative to the what? Relative to the moving sidewalk, not relative to the person outside. So that what means what? Relative to someone, look, everyone, two people now are on the sidewalk. One not moving, just moving with it, and one who's actually what? On it and moving what? On the sidewalk. Okay? All right. How much time does she require to reach the opposite end if she walks? In the what? Or the opposite direction. Okay? All right. So okay, let's let's sketch a quick diagram first. Do you have one slide with it? Yes, okay. So everyone, let's sketch a diagram like this. So from here to here. Let's say everyone, let's say it's moving to the right. So the sidewalk is moving at 1 meters per second this way. Okay. We have how many situations for the person on it? How many? Two. Either moving with it or against it. Okay. Either way at the same speed, which is 1.5. So everyone, part A, look, I want you to write this way. Part A, sketch someone moving with it. At what speed? And for part B, move someone going what? Against it, also at 1.5. Okay? Can we identify the objects here? What are the three objects that need to be identified, whether for part A or for part B? Let's just focus on part A first. What's object number 1? I mean, you could just read the problem and get the names of the object. The moving sidewalk, the actual sidewalk. Okay. What else? The ground. There's always a ground. By the way, you always need, well, almost always need what? An absolute observer. Okay. And the person walking, in this case, the woman walking on it. Okay, great. So we are going to need some subscripts here. So what do you think the subscript should be? What's the subscript for the ground? G, capital G. What's the subscript for the woman? Capital W. How about the sidewalk? Let's call it S. Okay, great. So everyone, maybe on top, go ahead and write um, W equals woman. Woman. G equals ground. And S equals sidewalk. Okay, all right, let's do part A. Question, what does part A want? Actually, what do both parts A and part B want? The velocity of who according to what? They want they want how much time? But obviously, to do time, you need what? You need speed, right? Because time equals a distance, which is the 35 meters, over what? Over speed. So we need the what? We need the relative speed or the relative velocity of the woman according to who? The person where? On the what? On the ground. Okay, so we want, everyone, we want V, W, G. Can someone finish this relative motion equation for us? I've already given you the two subscripts. You just have to play with the subscript on the right side. Ahmed, give me the first one. So VWS, yes, exactly. V W S plus, who would like to give us the second one? C, so SG, exactly, SG. All right. By the way, is this a 1D or a 2D problem? Do we need triangles and stuff? Can we move straight ahead with the actual numbers and the directions? Yes. By the way, this is like the displacement problem you had yesterday in your quiz. East, west, that kind of stuff. Okay. Now, everyone, in part A, what's the velocity of the woman according to the sidewalk? It's already on the diagram. 1.5. Going which way? Right or left? Again, part A, she is moving. Remember, they all have the same grid, right? They all have the same grid. So this person has the same grid as this person, as the person who's standing on the sidewalk, just watching her move. So that means, you know what? Let's not use right and left. Let's use what? East and. All right, go ahead. Right, west here. And east here. Okay. So 1.5 meters per second east plus east plus what? 1 meter per second east. Yeah, I mean, the ground observer just sees the sidewalk, whether there's a person on it or not. Move 1 meter per second that way. Great. So 1 meters per second. How much is that? Exactly. Because obviously, do the directions need to be flipped? Nope. Straight ahead with the math. So I'm just going to put this a bit up here. 1. So equals what? 2. Sorry. By the way, does this answer make sense? Yeah. If she's already walking on the sidewalk and the sidewalk itself is what? How does she seem to move? Really what? Really fast. Exactly. 2.5 meters per second. Okay. We got distance. We got speed. How can we get the time? Time is what over what? Because distance, by the way, distance is the only one that's the that's the multiplication of the two. Either of the other two is the division. Okay? If you want time, divide distance by speed. If you want speed, you divide distance by time. Because remember, how many people remember this triangle? What's on top here? D, distance. What are here? Speed and time. And how do you use this triangle? Whatever you want to find, hide it with your hand. If you want to find distance, you hide it. So what do you do with those two? Because they are on the same level. What if you want velocity? You hide it. So what happens to distance and time? We actually want what? We actually want time now. So we divide. Perfect. So delta t equals, what's the length of the sidewalk? 35 meters divided by 2.5 equals 10, 11 point something probably. 35, yeah, definitely 11. Oh, 14? Oh, 35. I thought it was 30. 14. So 14 what? It's time. So it's what in this case? Second. Awesome. That's it. Everyone, question for you. What if she's walking? This is not the example, but what if she's walking? Everyone, pencils down. Just give it a thought here. What if she's walking at 1 meter per second opposite to the sidewalk? How would she seem to move to someone on the outside? She wouldn't. Okay, so to someone on the outside, she's going on a treadmill, right? She is in her what? Staying in her what? In her place, in her spot. So what's her speed according to someone on the outside? Is it making sense? Okay. So how long is it gonna take for her to cross the sidewalk? Say again? Forever. What's a number for forever? What's a symbol for forever? Infinity. Is it making sense so far? What was her speed again? What's 35 divided by 0? What's any number divided by 0? Infinity, undefined. Is it making sense now? This is what this problem is telling you. She has to walk definitely what? More than what? Sorry, this is not 10, this is 1. She has to walk faster than what? 1 on the other direction if she has even a chance of what? Somehow getting to the other side, right? Because on the treadmill, you never get to the other side, right? You always what? Stay on your place. Which means what? How long is it going to take you to cross a treadmill? Undefined forever. Why? Because you're dividing by 0. Do you see how the physics agrees with the math? There you go. Well, she has actually more than 1 meter per second, so she is going to definitely what? Make it to the other side. But this time, is it going to take her the same time or much longer? Why? Because she's actually what? Not beating the what? Not beating, but actually she's losing some speed to it. That's fine. All right. So do I still start with the same way? 100%. Everyone, does this change? How about this one? Not magnitude, direction. Now she's walking what? West. Perfect. Yeah, go ahead. B, VWG. By the way, yeah, we have to start with the same equation. VWG, still VWS plus VSG equals equals 1.5 meters per second, but now in the west direction, plus 1.0 meters per second in the east direction. I'm going to take out the triangle because we don't need it anymore. What must happen here? Come on. One direction has to be what? Flip. Now you could flip to get a negative or a what? Always flip to get a positive, which means what? Flip the smaller one, because then the bigger one wins. So that means 1.5 meters per second west minus 1 meters per second also west, which means how much speed does she have now in the west direction though? 0.5. 0.5 meters per second west. Everyone, question. What's 0.5? What's 0.5 compared to 2.5? What's 5 compared to 25? What's 5 compared to 25? 1/5, right? So she's 1/5 as fast, which means how long should it take her now? 5 times longer. Make sense? If you're 5 times slower, it's got to take you 5 times longer. Provided that what stays the same? The distance stays the same. You got it. You always have to fix the multiplication. So that means delta t now is equal to 35 divided by 0.5. And I don't know how many of you know this trick. Whenever you divide by 0.5 or a half, you end up actually multiplying by what? By 2, because you're really dividing by a fraction. So when you flip it, you really get to multiply by 2 by 1 instead of dividing by 1 and 2. So that actually takes 70 seconds. Yep, 5 times as much as before, which makes sense because now she's getting slower. By the way, do you see how it might seem like 1D problem are trickier to understand than 2D? To me, it was always like that. Yeah, go ahead. To me, it was always like that. You know why? Because 2D problems are so easy. Because 2D problems, you always sketch a what? A triangle. You can see everything in front of you. What's the problem with 1D? Is there a triangle? No, you have to imagine in your head one vector going this way and the other one vector what? Or with it. Do you see what I mean? That it always was trickier for me to do 1D more than 2D. 2D is so visual, you see it in front of you. You know exactly how it's going. 1D, you're like, which one is winning? And according to whom? That's why. Okay, so that's why I like to do a couple of 1Ds first. Okay? In a soccer match, Juan is running which way? Due north, okay? Towards the goal with a speed of 8 meters per second relative to the what? So relative to someone standing on the ground, just watching them, they see them move north at 8 meters per second. Good. A teammate passes the ball to him, okay? All right, so he doesn't have the ball yet. The ball has a speed of 12 meters per second and is moving in a direction of 37 degrees east of north relative to who? relative to also the ground. So on the same ground observer sees, the absolute observer sees the ball move at 37 east of north or northeast. East of north in our way means northeast or north 37 east with a speed of 12. What are the magnitude and direction of the what? Relative to who? So as Juan is running due north, how does he see the what? Is it making sense now? So how come this problem is different than all the ones we did before? How many things are relative to the ground in this problem? Two. Usually, how many things are relative to the problem, relative to the ground, given the problem? One, and you're asked about the other one. This time, both of them are relative to the ground. You're asked for the what? For the one that's not relative to the ground. That's fine. All right. So let's do the problem. Okay. Uh, let's actually just start by writing the subscripts. What objects do we have? What objects do we have? Juan. Juan. Yes. So that's a J for sure. Come on. Ball. So B. Any air or wind effect? Nope. Great. So J. Juan. G. Ground. Ground. And B ball. Okay. Can someone tell me what's this 8 meters per second relative to the ground? V what to what? Just give me the subscript. V what to what is the 8. So it's V of him to the ground. Great. So let's actually, everyone, let's do the ones here, the givens here. V J to G is 8. I'm gonna skip the decimals, so I'm just gonna write which way north. Okay. How about V? What's the other one? What's that 12 meters per second of the 37? What to what? What to what? Ball to the ground. Yes. So B to G, which is 12 meters per second. In which direction? Okay, we said east of north means northeast. So north 37. Oh, again, at the end, we'll just reference everything to 3 and 3 and 3. We're good. So east. What are they asking us to find? The what to what? Or who to what? Or what to who? Yes, the ball to J. Okay, so V, ball to Juan. Question mark, question mark, question mark. All right, give me a relative motion equation. So I'm going to write a different color. V, B, J equal. Who would like to finish this one on the right side? Raise your hand. Anyone? Something plus something. Hamad. Okay, Hamad, go ahead. But so V, Amar, what do you want to say? It, it should, because we don't have it, right? That's fine. Remember, we can always flip vectors. Everyone, do you see what Ammar is saying? Ammar is saying, Ammar already saw the end of it, and he's like, but one of those we don't have here, right? That's fine. Remember, what did we say? Remember when me and Josh were moving against each other? You just flip the direction 180 degrees. Okay, so it's okay. I'm gonna move. I see him move this way, right? So I see him move east. But how do you see move? He sees me move what? West. Do you see what I mean? So always V Ramadan to Josh is equal to what? Negative, or flip the what? Josh to Ramadan. Do you see what I mean? You can always just what? Flip it, and that will give you the J, B, B, J, and so kind of thing. Make sense? You always have it. You just need to know what to do with it. All right. So, Muhammad, what was it? B what? To G, G, J. Good. That's fine. That's absolutely fine. One second, let me just update attendance, everyone. Okay, which one of those two do we have ready for us? Which one of those two do we have given to us explicitly? Which one? The BG, right? Which one is flipped for us? Instead of JG, we need what? GJ. Okay, how would you flip that? Instead of 8 meters per second north, it would be 8 meters per second what? So, do you see what okay, everyone, pencils down. Shadi, can you just crouch right here like this? And I'm asking him to crouch because he would be the ground. Okay? Yep, good. I am Juan, right? I'm moving which way according to the ground? So he sees me what? Shadi sees me go which way? How do I see him move? Exactly. Is it making sense now? Just flip it. Thank you. All right. So we're going to do equals. I'm going to do it in green because we know things now. Equals. BG is what? 12. Let's skip the units. Okay, it's I don't have enough space. So 12 north 37 east plus 8. Which way? We said it has to be flipped. So it's 7. Do you think this is a 1D problem or a 2D problem? Come on. It already has what? It already has north and east. I don't care what it has here. It already has north and east. So do you think we should sketch a quick diagram? Probably. Okay. What's the scale between 8 and 12? Everyone, always divide the big by the small. Go ahead. Divide 12 by 8. It gets you exactly what? 12 by 8? 1.5. So just make the second vector slightly what? So 1.5. Sorry. Yeah, half bigger. Okay? Or just make the second vector, so the first vector slightly bigger than the second one. Whatever. Okay. So we have to start, and which way do we have to go first? North 37 east. Can someone point with their hand which way is north 37 east? Yeah. You just have to go their way, right? North, east, so somewhere there. Okay. All right. So I'm going to do the diagram here, everyone. So, okay. Everyone, pencils down. Let's just imagine the situation. Which way do I have to go first? Eyes on me. Which way? North, east. And from here, what's my second vector? North or south? So I'm going to have to sketch a line this way, and then a what? A line this way, right? Okay. So from here, there, okay, north 37. So somewhat like this. How much is this? 37. Yeah, you got, because it's between north and east. And then my second vector would go up or down. I'm gonna make it shorter a little bit. Okay, we have to do the cosine law. Can someone tell me how to find out this angle? Because that's the angle between the two sides, I know. Raise your hand if you see the theorem, the geometry theorem we need to use. Noura, say. Where's the Z though? You have to look like this, right? That's fine. Is that Z? Of course it is, because this is perfectly vertical, and this also is perfectly vertical. So how big is this angle? 37. Again? Oh, okay. I thought you said how. Okay, so 37. Okay, cosine law it is. Cosine law it is. So yeah, I'm gonna show you a quick way of writing the sine law. I'm just gonna write c squared equals a squared plus b squared, because we know which one we were trying to find, right? We're trying to find which one? Which side are we trying to find? This guy, right? So if I call this c, small c, that takes care of what? This is a, sorry, this is a and this is b, right? Is it making sense? I'm just using what? Quick notation, even without showing it, because we've already seen it done so many times. So let's go ahead with c squared. Go ahead. C squared equals. Now, what's a squared? Yeah. So, okay, or 12. Yeah. So 12 squared. Let's jump straight to the numbers. 8 squared minus, whoop, minus 2, nothing, just 12, 8. Cosine of what? Question, everyone. Does this seem to be longer than this? So we're expecting what? A final answer that's less than what? Or maybe even less than what? Why is that? Because this minus will not be made positive. Do you see what I mean? Cosine of big angles more than 90 will lead to what? Will lead to an answer bigger than either of the first two. Why? Because minus a minus will give you what? Which means the whole thing will be bigger than before. But when this one is positive, this one will stay minus, which means the final answer will be smaller than at least one of them. Good. So let's do the final answer. Let me do my method with the calculator I showed you. All right. So let's do this. So which side of the calculation do I start with? Yes, the one that is the most elaborate. So make sure you're on degrees, of course. Mine is always this. 37 cosine. See? Positive. No problem. As expected. It's in quadrant 1. Sine 8 times 12 times 2. Okay, I'm going to make it what? I'm going to make it negative. So I'm going to make it negative. And then because I made it negative, I'm going to add it to the rest. What's 8 squared? And what's 12 squared? So that is 54. I'm just going to write 5466, which means my final answer is square rooting this. 7.39. We're going to go with 7.4. Is it 3? Sorry. 7.39. My bad. Which angle do you have to give me? Where's the start angle? Can you point to it? No, no, just the start. Just the start in the triangle. Where is it? Right. No, not this one. Yeah, right here. This is where we started moving from. So we want to get this thing. All right. So obviously sine A over A and so on. So sine, I don't know it, so I'm going to call it question mark over A. Where's A or whatever? 8 equals sine. Sine what? You have to use the other angle that you know. Divided by the opposite to 37, which is why we did the cosine law in the first place, to get 739. Crisscross, play with it, sine inverse. Everyone, I'll show you an easy, again, if you ever want to jump to the final answer, sine inverse. Look, everyone, sine inverse. I know we have just a few minutes, just finishing up. Sine inverse. This times that divided by that. So 8 sine 37 over what? All right, equals, let me do the sine 37 first. 37, almost done. Sine times 8 divided by what? Gives me a decimal, which is good news because I could sine inverse this guy. How much is my angle? 40 point what? Point 7 actually. Yeah. Okay. $40.7. Everyone, but that's only this much. Remember, we need something in a quadrant. Can someone tell me how to add how to get the final answer for the angle? So yeah, exactly. You can add 40 to what? 37, and then you're relating it from the what? From, well, which direction? North. So north, 40.7 plus 37 is 73.7 northeast. So my final answer is V. Who? It was Vol to Juan. Vol to Juan equals 7.39 meters per second. So 40.7 plus 37, 73.7. And it's north. Sorry, you're right. I can't even edit it. Thank you. Yeah, I looked at this tree. Thank you. You see, he corrected me. That's great. 77. Yes, thank you.